Hello, and welcome to today's tutorial. We are going to explore SCL, which stands for Structured Control Language. This is the first video in a series where we will build a complete storage system using SCL. It is important to know that SCL is a very specific language used to create special functions. You usually do not program an entire PLC in this language, but you use it for specific advanced tasks. Today we are starting with the absolute basics, which is the IF statement. To demonstrate this, we will create a function block called storage system. Let us start by defining our variables. We need a way to track our storage, so we will create a variable called shelves. This will be an array of Boolean values ranging from 0 to 99, giving us 100 shelves in total. A value of false means the shelf is empty, and a value of true means the shelf is full. Next, we need our input variables. We need an integer called selected shelf to tell the system which shelf we are working on. We also need two Boolean commands, one called put in to add an item and one called take out to remove an item. Finally, we will add an output variable called error to alert us if something goes wrong. Now, let us write the logic starting with the basic IF statement. The syntax is simple. We write EF followed by our condition. For example, IF, the put in command is true. Then we want to execute a specific action. The action here is to update our shelves array. We access the specific shelf by using brackets and the selected shelf variable. We then use the assignment operator, which looks like a colon followed by an equal sign to set that shelf to true. We close the statement with end if. Now, when we activate the put in command, the specific shelf becomes true. However, we also need to take items out. We could write a second independent IF statement for the takeout command, setting the shelf to false, but this creates a logical problem. What happens if both the put in and take out commands are active at the same time? If we use two separate IF statements, the last one executed will overwrite the first one, which is not safe. To fix this, we need to structure our code properly using ELSIF statements. This allows us to prioritize our logic and handle errors. Here is the optimized structure we will use. First, we check for the error condition. We ask if put in is true, on takeout is true. If this condition is met, we set our error output variable to true. This immediately tells us that we cannot perform both actions simultaneously. Next, we use an ELSIF statement to handle the put-in logic. We say ELSIF put-in is true and takeout is false. If this specific condition is met, we set the selected shelf to true. Finally, we use another ELSIF statement for the takeout logic. We say, ELSIF takeout is true and put in is false. If this is met, we set the selected shelf to false. By cascading our logic this way, the program is much more efficient. The computer looks at the first condition. If it is true, it executes it and ignores the rest. If it is false, it moves to the next check. This saves processing power and prevents logical conflicts. So we now have a functional storage system that can add items, remove items, and detect errors if both commands are sent at once. In the next video, we will expand on this system by looking at loops, including the for loop and the while loop. If you found this helpful, please like and subscribe, and I will see you in the next episode.